Hello everyone, this is Heading Tian. Today's video, we're learning 2.1 basic of functions and their graphs. First, let's see the relation. A set of ordered pair is called a relation. So one from the ordered pair could be X, another one could be Y, X, Y. So X can be any number, Y can be any number, real number. A relation can be represented in several different ways as ordered pair, a table in a graph with a mapping or an equation. So let's see some relationship. First one, that's the ordered pair. The first element in the parentheses, we say this is the X. Second element, that's a Y. Between them, we use a comma. Second one, the relationship between X and Y, they are -2 and 4. The last point is 0, -3. We can also list them in the table. All the X value is here, all the Y's value is here. And the next relationship, oh, I want to clean this. Next relationship is graph. So we can draw a XY coordinate plane. X-axis, Y-axis is a vertical line. X-axis, that's horizontal line. Any point on this XY plane, for example, if I have a point 1, 2, this point, X value is 1, because if I draw vertical line, here the X value is 1, and Y's value, draw a horizontal line, here is 2. So this point is 1, 2. And next point, if I'm looking for -2, 4, so X value for this point is -2. Y's value of this point is 4. So any other point has all has the X and Y's value. So this is a two-dimensional. That means any point on the XY plane must have a XY's value. We can't say the point on the XY plane has only one value, even if here X equals 0, but that's still the value for the X. So I can't say we don't have a value for the X. Next relationship, we say mapping. Mapping, we start from the domain. Domain means all X value, and the range, that means all Y's value. So from the X to the Y part, from domain to the range part, that's a projection. The X values of the relation are known as the domain. So the domain for the listing points, so we can say these are the points on the XY plane. All the X value is known as the domain. So domain is 1, -2, 0. We can list all of them in the set. -2, 0, 1. So the order doesn't matter. If you want to list them in another way, if you list them like this, 1, -2, 0, that's totally fine, because this is a set. The Y's value in the relation are known as the range. So list all the value. If I use different color, list all the Y's value in the set, that's a range. For the relation to be a function, there must be only one output Y for each input X. Simply, X cannot have more than one partner. If these conditions are met, we say Y is a function. That means we can have a relationship like this, X to the Y. And also we can have another X. For example, this is X sub 1, X sub 2. X sub 2 is mapping to, this is Y1, Y2. And also we can have another relationship that X2, X sub 2 is also mapping to Y sub 1. That also means Y cannot have more than one partner, but X cannot have more than one partner, but Y can have more than one partner. Okay, let's see next example. So Is this one a function? If it's a function, the same x cannot have two different y's value. Let's see, the first point, 3, 4. So 3 is here, y's value is 4. Next point, 3, 5. So they are same x value, but they have the different y partner. That means this is not a function. Let's put this, not a function. And another 2 points, 4, 4, 4, 5. Okay, same y, same x, different y. Okay, this is not a function. And let's list the domain and the range in the set notation. Domain means all x values, so list all the x. We can put 3 and 4. There's no repetition because I know that 3 appears twice, but we only keep 1 in the set notation. You don't need to list 3, 3, 4, 4. Okay, let's see range. What is the meaning of range? Range means all the y's value. So let's see all the y's value. We have 4, 5, 4, 5. That means we don't need to list the repetitions. We only need to list 4, 5. Next example, is this one a function? Let's see. The first point, 3, -2, 5, -2, 7, 1, 4, 9. So each x has only one partner. Even I know that 1y has 2 x partner, but it doesn't matter. There's still a function. Let's say, let's put the solution here. Yes. Yes, a function. And domain lists all the x value here. 3, 5, 7, 4. Let's see the range. Range means all y's value. -2, 1, 9. Even -2 appears twice, but still lists once in the set notation. Let's see vertical line test. To be a function, every x value can only be paired up with only one y value. Therefore, if any vertical line intersects a graph in more than one point, the graph is not a function. Okay, let's try. How does it work? So by the definition, if I draw a vertical line, if I can get to one point or one intersect, this is a function. If I have more than one intersect, this is not a function. Why? Let's draw a vertical line here. For example, vertical line. And I have 2 intersect. So tell me, what is the, for example, this point is 1, 1. And this point is 1, -1. Because this point, x value is here, y's value is here. We say this is 1, 1. Another point is they have the same x value, but different y's value. Okay, if I have 2 intersect, so x, they are same, but they have different y's value. Okay, one x has 2 partner. Okay, this is not a function. No. Oh, that means if I can use a vertical line test. One intersect, that's a function. More than one, that's not a function. Let's try next example. Number B, vertical line. Yes, only one intersect. If I draw anywhere on my plane, I'm going to have one intercept. So yes, this is a function. Next example, let's draw a vertical line. We have only one intercept for each vertical line. This is yes. Let's try next one. I'm going to have 2 intercepts, so not a function. Let's try another way to determine the equation is a function or not. In previous method, if I have the graph, I can test, use the vertical line test. But if I give you an equation, I don't provide you the graph. How to decide that equation is a function or not. So here is a hint. If y has an even power, then it will not be a function. Okay, just need to try to see if all the y's value or y has the power is even or odd. If it's even, it's not a function. Let's see its first one, x plus y equals 16, number 11. Is this a function? Yes, it is, because the power for the y is 1. So this is a function. If you have, you can draw them on the xy plane. This is a straight line. So if you draw a vertical line, you have only one intercept. And so someone will ask me how you draw the picture or how you draw your graph. You can pick some point. For example, if x equals 0 and plug it in the function, the equation, find y's value, x equals 0, y equals 16. So x equals 0, y equals 16. Maybe here is 16. And another one, so 2 points can decide a straight line. So next one, I can say y equals 0, or let's y equal to 0. Here is 0. We only have the one x. So x equals 16. Another point here is also 16. Line them up, you can find the graph. But here we don't need you to find the graph. Just want you to decide if it's a function or not. So yes, it is, because the y's power is odd, it's 1. Next example, number 13. The y's value, the y's power is 1. That means yes, it is a function. And the graph of this function is a parabola and concave downward. Next example, is this a function? No, the power for the y is even number. Even number means 2, 4, 6, -2, 4, 6. They are all even number. And so is this a function? No, because y has an even power. And this one is a circle. So if you know the graph, you can draw a vertical line. We have 2 intercepts. Okay, next one. Is this one a function? No, because the power is even. The power for the y is 2. And the graph of this function is like this. So if I draw a vertical line, we have 2 intercepts. Okay, let's see next example. Is this one a function? Yes, the power for the y is 1. So I should put yes first. And then the graph of this function is like this. So you draw a vertical line. It has only 1 intercept. Okay. Okay, next example. Is this one a function? The power is 3. So we put yes, because 3 is odd number. It's not even. And the graph of this function is like this. So if we draw vertical lines, we have only 1 intercept. Okay, let's move on to see next part. Find the function values. Equations that are functions can be written in a form called function notation. For example, consider the relationship x and y. Y equals y equals 3x minus 8. And if we isolate the y, or leave the y on the left-hand side of the equation, this is also can be written as f of x equals 3x minus 8. So y and fx, they are the same thing. That means the output value or the y's value. And the function, you can imagine that the function is a processing machine. Here is the machine. We call this is the f function. And it's the parentheses here, we call that the input part. When the input value I put x here. Then the processing machine will process in its inside, and that's the 3 times x minus 8. If now, the input, I will put a 3 in it, for example. So all the x need to be replaced by the 3 because the input is x. If I put the 3 in it, so 3 times 3 minus 8 is 9 minus 8 is 1. So that's how we express a function by this way. For example, if the input becomes 5, so we replace all the x by 5. So the x here need to be replaced by 5. So 3 times 5 minus 8. That's 15 minus 8. That is 7. Okay, let's see next part, some examples. First example, the function f of x equals 4x plus 5. So if you have this f of x, so f of x, we call the function like this. So f of x equals 4x plus 5. We are looking for f of 6. That means the input is 6. All the x need to be replaced by 6. 4 times 6 plus 5 is 24 plus 5 is 29. Next example, let's see what is the input. Input is x plus 1. So 4 times, all the x need to be replaced by x plus 1. X plus 1, x plus 1 plus 5. We need to distribute the 4. 4 times x, 4x. 4 times 1 is 4 plus 5. We have 4 plus 9. Oh, no, 4x plus 9. Next example, we plug in negative x in the function. So 4 times negative x plus 5. So 4 times negative x is negative 4x plus 5. Okay, let's move on to see next example, number 29. G of x. G of x equals x squared plus 2x plus 3. And we plug in x equals negative 1. So all of the x need to be replaced by negative 1. Negative 1 squared plus 2 times negative 1 plus 3. And what is negative 1 squared? Squared means negative 1 times negative 1. So negative, negative, positive. 1 times 1 is 1. 1. And the next term, 2 times negative 1. That's negative 2 minus 2 plus 3. So 1 minus 2 is negative 1 plus 3 is positive 2. Next example, number B. Input is x plus 5. X plus 5 squared plus 2 times x plus 5 plus 3. And we know that squared means x plus 5 multiplied by x plus 5. And you can FOIL this, x times x times 5, x squared plus 5x. 5 times x, 5x. 5 times 5 is 25. And combine like terms. That is x squared plus 10x plus 25. You can also use the perfect square formula, which is if I have a plus b squared and expanded, we have a squared plus 2ab plus b squared, and plug in the ab's value. Okay, let's come back to the question. X plus 5 squared. So we already solved that. That's x squared plus 10x plus 25. And here we also need to distribute the 2 in the parentheses. We have 2x plus 10 plus 3. Combine the like terms. So these are the like terms, And these are the like terms. That's x squared. 10x plus 2x is 12x. And 25 plus 10, 35, plus 3 is 38. Okay, let's see number C. The input is negative x. So negative x squared plus 2 times negative x plus 3. Negative x squared means negative x times negative x. That's positive x squared. And 2 times negative 1 is negative 2x plus 3. Okay, let's see next example. H of x equals x to the fourth minus x squared plus 1. Now we are looking for h of 2. The input is 2. So 2 to the fourth minus 2 squared plus 1. What is 2 to the fourth? So 2 to the fourth equals 2 times 2 times 2 times 2. The multiplication of the 4 twos. So 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So we can put 16 here. 16 minus 2 squared is 2 times 2 is 4 plus 1. 16 minus 4 is 12. 12 plus 1 is 13. Next example, the input x becomes negative 1. So negative 1 to the fourth minus negative 1 squared plus 1. Let's see, what is that? Negative 1 to the fourth equals negative 1 times negative 1 times negative 1 times negative 1. So negative 1 times negative 1, positive 1, because negative, negative, positive. And here, negative, negative, positive, positive 1. 1 times 1 is 1. So remember that if the power is even and the base is negative number, I don't care what is that, maybe negative 1/2, negative 24. So if it has an even power, the result must be positive. For example, so I will show you an example later after solving this. So negative 1 to the fourth is 1 minus negative 1 squared. That's still 1 because here is even and base is negative. Plus 1, we have 1 because 1 minus 1, 0, 0 plus 1 is 1. So if I have any negative number, for example, negative 2, and I have the power, for example, I have 1. So that is negative 2. If negative 2 has squared, the power is 2. Is negative 2 times negative 2 is positive 4. If negative 2 cubed, so this is cubed means negative 2 times negative 2 times negative 2. So negative, negative, positive. Positive times negative is negative. Negative 8. Remember that if it's odd number, with the result is negative, like these two. If it's even, like 4, 8, 6, 16, we have positive solution. Okay, let's see next, number C. H of negative x. The input is negative x to the fourth minus x squared plus 1. So what should I have if the power is even and the base is negative? Yes, it's positive, and positive x to the fourth minus, here I forgot to plug in the value for the x. Let's erase this part because I know that the x need to be replaced by all of them be replaced by negative x and negative x squared. This is even, base is a negative number or negative variable. So this one equals positive x squared. And next part is plus 1. Don't forget plus 1. Okay, let's see next part, number D. The input is 3a. So 3a to the fourth minus 3a squared plus 1. If in the parentheses, the base is multiplication. That means I can raise 3 and a to the fourth power. Raise the a to the second power. That means 3 to the fourth times a to the fourth minus 3 squared, a squared plus 1. And what is 3 to the fourth? That's 3 times 3 times 3 times 3. This one is, is 9. These two are 9. 9 times 9 is 81. 81 a to the fourth minus 9a squared plus 1. Okay, let's see. Example 32. Now we have the h of x equals x cubed minus x plus 1. Number 8, input is 3. 3 cubed minus 3 plus 1. So 3 cubed equals 3 times 3 times 3 times 3. That's 27. Minus 3 plus 1. Minus 3, 27 minus 3, 24. 24 plus 1, 25. Okay, let's see next example. Number B, h of -2. -2 cubed minus -2 plus 1. -2 is even or odd for the power. It's odd, so the solution must be positive or negative. Negative, right? Because base is negative and power is an odd number. So we have negative. -2 equals -2 cubed. So I can pull out the negative sign in front. 2 cubed, that's 2 times 2 times 2, that's 8. It's 8. Minus negative means plus 2, plus 1. This is -5. Number C, the input is -x cubed minus -x plus 1. What do we have? So power is odd, and in the parentheses, the base is negative. So we have -x cubed minus negative means positive plus x plus 1. Let's see, number D, input is 3a. 3a cubed minus 3a plus 1. So we can distribute the 3 because inside is multiplication. 3 cubed, a cubed minus 3a plus 1. So 3 cubed is 3 times 3 times 3 is 27. A cubed minus 3a plus 1. Okay, let's see next example. F of r equals square root of r plus 6 plus 3. All the r need to be replaced by the -6 in the number A. So square root of -6 plus 6 plus 3. In the radical sign, we have -6 plus 6, that is 0, right? We have 0 plus 3. What is square root of 0? That is 0. 0 plus 3, that's 3. Next example, number B. Square root of r is 10 now. 10 plus 6 plus 3. Square root of 10 plus 6 is 16 plus 3. We have square root of 16. That's square root of 4 squared plus 3. Square root to square canceled. I have 4 plus 3. That's 7. So some of you may confused about this and the previous example. If I need to square root x, if I have x squared equals 4, and I square root both sides, I must have a positive or negative sign here because I'm square rooting a variable, a known number. If here 16 is known, that's a positive number. We don't need to have positive or negative solution. So we have positive 4 here. Okay, let's move to number C. Number C input is x minus 6. Square root of all the r they are replaced by x minus 6 plus 6 plus 3. Someone will say, do you need a parentheses? Yes, you can. You can add it. If without it, it doesn't matter because that's the first term. Okay, square root of x minus 6 plus 6. And then plus 3. Minus 6 plus 6 canceled. Square root of x plus 3. Okay, let's see. Next example, number 35. Number 35, x equals 4x squared minus 1, all of them divided by x squared. Now the input is 2. 4 times 2 squared plus 1, and 2 divided by 2 squared. Let's solve this. 4 times 2 squared, because the exponent goes first. We do the exponent first. 2 squared, that's 4. And the bottom is 4 because 2 squared is 4. On the top is 16 plus 1. That's 17. So we have 17. Is there something wrong? Yes, I always copy the wrong question. Remember that this is minus. You can't have plus here. So be careful. So I always made the mistake like this. So I need to redo my recording. So I need to record multiple times, because sometimes when I bring down the terms, I will bring down the positive. Be careful, you will lose the point if you do this like me. Okay, let me erase this part, and remember this is a negative sign. Okay, 16 minus 1 is 15, 15 over 4. Let's see. Next question, f of negative 2. So 4 times negative 2 squared plus 1 over square root of 2, over negative 2 squared. Power, what is the power? Even. What is the root? Negative 2. So we must have 4 times 2 squared, because negative root, but even power. There's no negative solution, it's positive solution, plus 1. And denominator is also the base is negative 2. The power is even. I have 2 squared. Do I copy the wrong? Why? Yeah, here is minus. Remember, it's minus because the question is minus. So let's do the exponent first. 4 times 2 squared, that's 4. Minus 1. The bottom is 4. We have 16 minus 1 over 4. That's 15 over 4. Next example, I must be more careful when I bring down the terms. So 4 times negative x squared minus 1, not plus 1, and negative x squared. Let's simplify this. The power is 2 for the negative base. We have a positive solution. 4 times positive x squared minus 1. And negative x squared at the bottom is x squared. So did you see something very interesting? This solution and the original function, they are the same. For this kind of function, when I plug in the x and or the negative x, I'm going to have the same expression. We call this function even function. So we will learn this later in chapter 2. So don't worry now. I will not ask you this function is even or odd function, but you can put this in your mind. Maybe later you'll meet the same question. Okay, let's see. Okay, we finished this part. I hope there's no mistake because this part I made some mistake here. It's negative, negative. Okay, enjoy your day and let's meet next video. Have a good one. Bye-bye.